Hi, good afternoon. This is a sound check. Can you guys hear me? Okay, thanks very much. Just give me a minute. I will just check a few settings, then we'll go. All right, so good afternoon and welcome back to the second half of the semester. As usual, today we have Kang Xiang with us. And today we're going to discuss tutorial 6, okay? Which will be about addressing instruction sets and also addressing modes and formats. So this will be our last tutorial for the topics that I will be covering, all right? So Dr. Manmeet will have a set of tutorial questions starting next week, okay? All right, so I will now break you guys into the breakout sessions. Just give me a minute, yeah?
Okay, so welcome back to the tutorial. So today we're gonna do tutorial 6. Okay, so I hope you have done tutorial 6. I mean, at least you try. Okay, although I know you have a busy, SEM break. Yeah, last week. Okay, even it's a SEM break, right? Okay, so let's go for the question. Okay. Okay, so yeah, today we are gonna just call up and see, to share your answer, and then we can discuss about that. Okay, so let's go for question 1 first. Okay, question 1, actually we have, okay, let me share first. Okay, for question 1, actually you need to evaluate this, okay, for the program using this, and then basically you have 0 address, 1 address, 2 address, and 3 address. Okay, so just I randomly pick 4 of you to share your answer. Okay, number 1, 0 address, Arif, Izzuddin, And then one address, Bernard Wong. And then two address, maybe Coco Chung. And then the last one, three address, Lai Xin Xian. Yeah. Okay. Okay, Arif, are you ready? I mean, if you're ready, then we can go to, you can share your screen.
Okay, wait. Are you seeing my screen?
Yes. Yeah, you can start explaining. Yeah, just for the old address, although you show all the answer already. Okay.
Okay, this is for the zero address. So basically, I do the left part first. Push A into the stack, and then I push B, and then push C. So, and I do multiply. This is B will multiply with C, and then add. We add with A, and then I push D, I push E, and divide it. D divided by E, and I push F and multiply. So D divided by E will multiply with F, and then I subtract. So the left part will be subtract with the right part, and then I pop X.
Okay. So, I mean, how about the rest? Do you agree with the answer from Arif on the zero address? Yes. Okay. Yeah. Yes. Just one yes. How about the others? Okay. No problem. Okay. Arif, do you know what is the another name for zero address machine? I mean, what is the organization name called usually?
No.
No. Okay. If you push B, push C, that kind of thing, is look like what? It's a stack, right?
Yes.
Yeah, it's stack organization. Okay, I mean, zero address is also known as stack organization. Okay. Wait a moment. My push F is below push E. Why push F is below push E? Push F, push E. You mean? Wait, let me check. Okay, you push D, push E, and then push F. No, if you push D, push E, and push F, then you use a multiply, right? Is that what you mean? And then only you divide. Okay, do you think you will get the same answer? No. Okay, I'm confused a bit. Okay, thanks Arif for sharing. Okay, you can unshare. Yeah.
Okay.
Thanks. Okay. Let me see. Okay, let me check one by one first. Okay. Okay, let's go to Yusen Yap first. Okay. Can you speak actually? If you speak, maybe it's easier. I will share my screen and then you can speak through the screen, or you want to draw also can.
Hello.
Yes. Okay.
My one is the number 9 and number 8 terbalik.
number 9 and number 8 the ballet. So you means
yeah.
push D, push E, push F, then divide.
Yeah.
So means is E divide by E how? Oh no, cannot. The operation only can use on top of the two item.
Oh.
You understand what I mean?
Yeah. Okay. I understand.
Okay. So I mean, if those who don't understand, we do like this. You see, push A, push B. Okay, this is the stack. Push A, push B, and push C. Okay, this is the stack. I mean, the stack is like you doing the piling in your. I mean, when you do your house chore, you wash your dish, then you stack one by one. Okay, it's like your plate. Okay, so you push A, push B, push C, and then you do a multiply here at the step 4. Means that is B multiplied by C. It only take the two element from the first two element on the top to do the the operation. So means that in this case, in here, you need to divide this one D and E. Okay, I think this one done already. So I need to go to Pan Gong Sing. Okay, what you mean? You Pan Gong Sing, you multiply first or what? Yeah, maybe you can speak if you can speak. Yeah.
I did the same way. Push D, then push E, then push C, push F. Then I multiply.
And you multiply. Okay.
Then I go through divide.
Okay. Do you know the rules of multiplication and division?
Yeah. Not quite sure. I'm not sure. Not quite sure.
Okay. I mean, if you have plus and minus, what do? You do from left or you do from the right side?
Plus and minus?
Yeah.
Plus, do the plus first.
Do the plus first, then do the minus.
Yeah.
Okay, actually, no. Okay, for plus and minus, right? Plus and minus, you do whatever from the left side to the right side.
Oh.
Okay, then for
Okay.
the multiplication and division, you do from the left side to the right side. Also, okay, just imagine, let's see here. This one, let's say 6 divided by 2 times 5. Do you get the same answer if you do from the right E times F first? Yeah, the other also can answer. Do you think you can get the same answer? Like if you do D divided by E, and then another one you do first, and then another one you do E times F first. Do you get the same answer or not?
No, different.
Different answer, right? Yeah. So always remember, you need to do from left to right. So if you do from left to right, it means that you have to do this one first. So push D, push E, then divide first. Then only push the F, then do the multiplication. Okay, Gong Sing, understand? Can I?
Yeah. Okay.
Okay.
Yeah.
Good. Okay. Okay, so the next one is Bernard for one address. Okay, I helped you unmute already. You can speak, I think. Yeah. Okay. Okay, first tell me, when we are using one address, what register, or I mean, what component is involved in one address, the main component that involved in one address? Yes, correct. That's the accumulator. Okay. So, if you don't know how to explain, then How? Okay, let me ask the others. Okay, do you all agree with the answer from Bernard? Yes. Okay. How about the rest? Yes, also. Okay, seems everyone agree lah. So means your answer is correct lah. Okay, load D, divide E, multiply F. Okay, there's one thing. Okay, usually when we do the accumulator, okay, first tell me what is X. I mean, where is X? Yes. I mean, where are you referring if you are talking about the X? You check out, lastly, you store X, right? Means that you store the X at where? No. No. Okay, you see, when you have when you divide X, right? When you divide X, the divide X is already inside the accumulator already. So the next step is store X. So where you store the X? Where's the possible place that you can store? Operand. Okay. First, tell me where you store your data in your computer. Address location. Okay. The address location belongs to what? Belongs to who? I mean, what component? Just tell me what component is the address belongs to. Yeah, the memory, right? The memory, okay? The memory. So either whether it's memory, what can be a place that can store the X? Either is a register, either is a memory. One address in the memory, one location in the memory, okay? So my suggestion is that you don't use your X when you want to store the temporary register. Okay? Yeah. I will share my screen. Thanks for sharing. Yeah, but overall your answer is correct. Just that I just suggest you something else. Okay? Okay. Yeah, correct. I mean, that's the memory lah. Of course, when you see that. Okay, so in this case, right? Okay, so in this case, okay, actually you can, because you can use there's something called temporary register in the one address. So actually you can use a T0 to store. So after you do this cycle, okay, you actually can do a T store and then you do another one, okay. When you subtract, you just directly subtract from whatever you store in the temporary register. Usually this one will be referring to your memory location, okay, inside your main memory or whatever things. So this one is usually, you will take a longer way to store. So because you store it permanently, because you want to store the value permanently. So this will be used as the final output of this program, okay, when you want to store X. Means that store whatever inside AC into the memory location of X, okay? I mean, store the value to the memory location, okay? But that is not, the one that shared by Bernard is actually not the only answer. So if you want to do, you also can start from B first, okay? You can load B, multiply C, okay, at A. So you do this part first, okay? Can I know anyone do this part first? Any one of you do this part first? I mean, start from the left side first. The bracket from the left side. So I guess no, is it? It's a no, right? Okay. So why you don't start from the left side? Yeah, can anyone just reply in the chat, like why you don't want to start from the left side? Okay. Starting from the right seems easier. Okay. Correct. I mean, easier is a general term lah. So if you see, this one is start from the left side. Okay. So you see what's the difference? Can you tell me the difference if you start from the left side and right side? Yes, correct. More operation. More operation means that it's not efficient. Okay, not efficient enough, more step, so it will be less effective. Yep, correct. Okay, so there's of course a reason why you want to choose to start from which side. Okay, but of course, if you start from the left side, you are still correct. Okay, because this one doesn't ask you to do like the most efficient way. But if you can, of course, you do the most efficient way. I mean, for us also, it's easier for us to do that. Okay. Okay. So let's go to number 3. Number 3. Okay. Coco, right? Okay. No, sorry. To address Coco. Yeah.
Hi, can you hear me?
Yeah.
Okay, and this is my answer.
Okay.
So first I store D to X and then divide X by E. That means dividing D by E also. After that, multiple X with F. So it means the left, right. The right part is completed.
Okay.
So, yeah, I store X to T.
What is T?
Like just now you mentioned T0, something like that.
Okay, what is that? Temporary register.
Yeah. So after that, I think this step I got it wrong. Should I store B first, right? Because from the front to the...
Okay, for B and C, it doesn't matter, but I mean, later you can always start from the left side, but it's still okay. Yeah, okay, still okay.
Okay, so I store C to X and then multiple X with B. That means multiplying C with B. Yeah, and then add them with A. So the right part is completed. After that, I minus X and T.
Minus X. Wait, 1, 2, 3, 4, 5, 6, 7, 8.
Is this
Wait,
okay? Okay.
Why? Okay. Okay. What is your X?
X.
X is what? What are you referring if you want to tell X when you say X?
Actually, I don't really understand this chapter. I just do this following the notes.
Oh, okay.
I'm sorry.
So yeah, I think because of that you make you confuse about, okay, remember just now I say, right, X is the place that you want to store your final result. You see, X is equal to the whole thing. So usually you only put X at the very last when you want to store the result.
Oh.
So when you want to do the other thing, you use a temporary register. Okay? Yeah. So I will share my screen. Okay? But anyway, thanks for sharing. Yeah. Coco?
Okay. Thanks.
Okay. So Coco where is almost there, just a bit confusing. Okay, when she's doing the, what is it? Yeah, she's using the X. Okay, so you see from my screen, right? So, okay, in the to address, usually, okay, if you know lah, the to address should be something like this. It's like the opcode, the destination, and then the, what is it? The source address and the mode here. Okay, so usually you'll see that it's like do the thing. So what this one do here is like, okay, if you do from the right side, you move D into the R0. R0 is a general purpose register, usually in our commercial computer, okay, 32-bit general purpose computer. So because why you want to move it to the temporary register or the general purpose register? Because it's faster when you do the operation. It can directly go to the CPU accumulator for processing, kind of thing like that. So you are going this one. So you move the D to R0. Okay. After you do the D to the R0, then you can do the division directly. So this one is R0 divide E and then store in R0. Okay. And then the next one is, okay, because now your divide, after divide E, the whole thing is stored in R0 already. So now your R0 multiply F and store back into the R0. Okay, so this is done. R0 now store the whole part here already. Okay, so now the second part is this part. So this part is like you do the B first, then you do the C. So we use another register. Okay, we use another register which is like register 1. Okay, that's just now is register 0, now it's register 1 general purpose register. So your B, okay, R1, B store in R1. Okay, this is what meaning by mover. So your R1, okay, already store with B, B plus C, and then store in R1. Sorry, not plus, multiplication, multiply. Okay, and then store in R1. Okay, so now your R1 also have this one already. Then the next one is add. So you add your A lah. B times C plus A. Okay, then go back to that. And then finally, you do a subtraction between R0. Remember, your R0 is the whole thing here. Okay, and then your R1 is the whole thing here. This is R1. So you use your R0 minus R1. Okay, and then it store back to R1. But you are not yet complete because remember this one. This is the place. This is the value. Okay, if you remember, you do your programming CPT 111. When you do this X equal to something, right? This X actually is a variable. So just imagine this variable is the place that you want to store your value. Okay, so you still have one operation, need to put this value into the post location X. So what's the last value is? So it will be, you need to move the R0, whatever the result, to the X location. Okay.
Sorry, I have questions.
Yes.
So for the step 7, right? If I SUB and then R1 and then R0, it's matter that the order of these two is matter.
Yes, it's matter. It's matter. This one step 7, right?
Yeah.
This meaning R0 minus R1 store into R0.
Also, I can't write like R1 and then R0, right?
Then it will be another way around. If you write, it will be like this.
So
yeah,
order
it will
is
store
matter.
it. Yeah, the order is matter, of course. It must be like, okay, let me see which one. This one multiplication. Multiplication is R1 multiply C, store in R1. Okay? Yep.
Okay, thank you.
Okay, and then any problem?
Hi.
Yep.
Sorry for this. Isn't that it should be for the step 7 should be sub R1 R0 because your R0 is D divided by E multiplied by F. But the question is the R1 minus R0.
Oh yeah, correct. Yeah, I think okay. Just now the one also saying the same thing, right? Okay. Yeah, I think it has a mistake here. Sorry. Yeah, it should be R1. Yeah, we got correct. This one is not okay, this one is correct. Sorry, yeah. Okay, it should be R1. Then this one, yeah, should be R1 also. Okay, move the R1 to X. Yes, correct. Yep. Okay, thanks for pointing out. Yeah, I mistake that one. Yeah, you see, sometimes it's really confused when doing this kind of question. Okay.
Sorry, I have another question.
Yep.
What if we move for the step 4, right? We move the B directly to the X so that at the step 7 we can just move all the things into X, so we save one interaction.
No, because when we're doing this kind of operation, right? You have to know usually the X are referring to the memory value, which is inside the main memory. So actually you need to go way further to get the result.
Oh, okay.
I mean, to put the result. So if you want to fast, you have to put it inside that. I mean, to prevent, you need to have more cycle to go to fetch the result or to write the result back into the memory and come back to your processing again. So it will have a delay in the micro operation. Yeah, you will learn about that later. Yeah.
Okay. Thanks.
Okay. Yep. Okay. So this one will take so much time. So okay, let's go to the last one. Last one is who? Xin Yi, right? Xin Xian. Oh, Xin Xian, right? Yeah. Okay, 3 address. Okay, so
So first, I will multiply the B with C and store in X. Then add A to X and store again into the X. For the second part of the question, it will be B divided by E and store in Y. And then multiply with X and store in Y. And the last one, I will substitute the X with Y and store in X.
Oh, okay. I'm so confused with your X and Y. Okay, wait me a second. Okay, yes, I think it's correct. Yep, correct. Okay, thanks. Yeah.
Thank you.
Yeah, okay, I just share mine. Okay, if any problem, just let me know. Okay, so I think my one is just something similar with what Xin Xian already shared just now. So yeah, okay, it's something like that. Okay, so just remember that the operation is actually like, for this one, it's like B times C, then store in R0. Okay, where usually why we use, because usually the operation is occurring inside the register, not the memory. Usually when we use X, Y, Z, that kind of thing, it's usually referring to the memory location. Okay, so this one is like A plus the R0, then go store in A0. Yeah, then this one is like the next one you do use another register, D divide E and then store in R1, then R1 times F store in R1, then finally you go use a R0. Okay, this time correct. This one this time correct. Yeah, so R0 is this one. R0 minus R1. Yeah, so you and then store in X. Okay, so with the three address, right, you can actually directly store. You don't need to do the move kind of thing. Yeah. Okay. So yep, I think that's it. If any problem, just let me know. Okay, so next one. Okay, so for question 2, okay, I think you already do the question. So what is the stack element remain after the following instruction has been executed? Okay, so look at the screen, look at my screen. Okay, and then tell me what is the stack element remain after the instruction has been executed, referring to the slide. Yeah, just reply in the chat. Hello, everyone still here? I think we just need the value. Oh, some got 18. Why you got 18? Okay. Okay, but first thing first. Actually, there's a trick inside this question. I told you to look at my slide, right? So actually, my slide is actually different from your slide. One line is different. Okay. So what is the stack element remain after the following instruction has been executed? Okay, anyone get what I mean? Okay. So okay, never mind. We just quickly go through that. Okay, let's decide whether it's 6.96, right? 6.96 or 18. Okay, so first, of course, you push 7, then you push a 4, you push an 8, and then you push a 2. So here, this side is the top of the stack. Okay, so this is the bottom of the stack. Okay, so you do an add. Okay, so means that 8 plus 2, 10. Okay, and then you push another 10, go inside. Then you do a multiplication, means that 10 multiplied by 10 equal to 100. Okay, and then you do a division. Okay, in this case, division is 4 divided by 100. Okay, 4 divided by 100 equal to 0.04. Okay, and then you do a subtract, means that 7 subtract 0.04 is 6.96. the order is important. Always the first element is the second top element. The second element, I mean, if you know what I mean, this one. This one is 4 divide 100, not 100 divided by 4. Okay? Okay, and then the thing is, because in this question, I use a pop result. After I pop the result, what is remaining in the stack? Zero is wrong too. Yes, correct. It's nothing. Okay, remember that. Huh? So if you don't have this pop result, then it's 6.96. Okay. Okay, this same thing. Okay. Okay, so let's go to question 3. Okay, so question 3, I think it's quite easy. So just make sure that when you do that, okay, for me, I always try whenever it's draw like that, I always try to draw something like this. So this is your memory. Then you have your, okay, this is actually the address, the word address. Okay, remember the one that we did. So this is the value inside that address. Okay, so when we load immediate 10, okay, load immediate 10, where is the operand? The operand is inside the value itself. So means that, if you imagine, then this one actually is something like this. This is your instruction. Okay, so what's the value of load immediate 10? Yep, correct lah. 10 lah. Okay, easy. Whatever inside the address field, then is the operand for immediate. Okay, load direct 20. Okay, load direct 20 means that you have to see whatever point by the 20. So again, this one is the same thing. So mean 20 is this one. This A is this one A. Okay, 20. So you go to the 20 and search. Like this one is point to here. So 40. Okay. And then next one, load indirect. Okay, you need to jump 2 times. Okay, so this one, again, draw like this. Then jump 1 time, jump to 20. Okay, then you need to jump another time, jump to 40. So what is inside 40? 60. Yeah. Okay, I think it's quite straightforward. If you have anything, just stop me in the chat. Okay, so the next one, okay, load immediate 30 means 30 lah. Okay, then load direct 30 means that, direct means that 1 time, right? So if you draw this, then 1 time point here, then it's 50. Then load indirect 30. Okay, then point here, and then point another time, 70. Okay. I think it's straightforward, so not much thing to take care of that. Okay, so for the last one, last one I think is a bit complicated, but just make sure that you read the thing properly, then you should be able to answer the question. Okay, so 16-bit, right? 16-bit processor, then you have the following main memory starting location. Okay, so evaluate one by one. I mean, here you separate. So the first part is actually a word, okay, that load a value into an accumulator, means load to AC, okay, and then following any mode, okay, mode is the addressing mode. Then the second part is, okay, sometimes it's a source register, then sometimes it's, okay, so if the source register is used, then there's R1, okay, the R1 has a value of 400. So this is a general purpose register, okay. And then there's also a base register, okay, it's BR, okay, store 100. Then the value of 500 in location 100 may be part of the address calculation. Okay. Sorry, not 100, this one is wrong. 101. Okay. Location 101 may be part of the calculation, so means this one. And then, okay, assume the location 999 contain 399 contain 999, and then 400 contain 1000. Yeah, that kind of thing. And of course, then you have 401 means that you have you have 1001, okay? And then if you have 500, okay, means that you have 11010, okay? That kind of thing, just consecutively, okay? So now you need to determine the effective address and also the operand. So of course, effective address, okay, always remember when you have the, this thing, okay? If you remember your operation mode, right? And then you have your address field here, okay? This is instruction. So this is the opcode, okay? Then this is the address field, okay, of the instruction, but effective address is the place, okay, where the operand is stored, the location of the operand, the address location of the operand is called the effective address, okay? So now we got direct, right? So direct, let me clean this. Okay, direct addressing, okay, of course, we know that this is like A, and then the operand. So usually it's EA equal to A lah, okay? So means that direct is, the effective address is 500, okay? So, okay, you just try to imagine, actually this is the address, this is the instruction that break into two lines. Actually, if you combine it, the 500 is here. This is considered one instruction, okay? So the effective is 500. So what is inside 500? Okay, so just now you already do the calculation, right? So where's the operand? Operand is in 500, okay? So means that this one actually is point to 500, 0.1 time only, you see, 0.1 time. So it's 1100, okay? So next, immediate, okay, immediate. So immediate means that the operand is directly at itself. So imagine again, the 500 is here, okay? So what is the EA? Okay, so because the operand, okay, actually you know the operand is 500 already, okay, because you know that this one is immediate. Immediate means that the operand is here. So what is the EA now? Can you type in the chat, what is the EA? Yes, correct. It's 101 because where is 101? I mean, where is the 500 stored at? It's stored at location 101. Yeah, correct. Okay. I think it's easy, right? Yeah. So C, indirect. Okay, indirect means 0.2 times. Okay, 2 times again. Okay, now you imagine, you imagine yourself. This one is the whole address. The 100 and 101 is the whole instruction. Okay, so where is your EA? Okay, so this is the content point. So means that 0.2 times, right? So you point this one the first time, you point to the 500. Okay, so the EA is 1100. Okay, so what is the operand? Because you need to point another time to actually get the value of the operand. Yeah, so another time point here. So this is your operand. So this is your EA. Okay. Okay, next one. PC relative. Okay, PC relative is a kind of displacement. Okay, but when you use PC relative, PC means the program counter. Okay, so okay, quickly type in the chat. What is the purpose of the program counter? I think you learned about program counter, right? Not personal computer. It's program counter. No responder. Really? Don't know what's PC? Oh no, that's mean, yeah, you guys really need to do revision on that. Yes, correct. actually it store it program counter actually point to the next instruction. So means that program counter actually is a register. So the register actually pointing to 104 means that it's stored to it pointing to 102. You see, because the current instruction is 100 ma. So the next instruction is 102. Okay? Yep. So in this case, displacement. Okay, so how you do the displacement? Displacement is like you use the A plus the program counter value. So your effective E is 500 plus your 102. Okay, this one reverse. So your effective address is 602. So what is inside 602? Okay, do the calculation again because you have this one already. So 602 should be 1202. Okay. Okay, so and then displacement. Okay, displacement. Okay, usually the displacement is like when I start a program, right? The program will have a very initial location, address location, the start of the program location. And that start of the program location usually store inside here, the base register. That's the base. Okay. So when you want to do, okay, you actually use displacement. A, this is R, this one R will be this one, the BR. So A plus base register, 500 plus 100 is 600. So the operand will be 1200. Okay. And the next one is the register. Okay, register. Register is a bit different. So now register EA equal to R. So means that the register is even the register by itself. So means that R is actually referring to this. Okay. So it's referring to R1. So we don't care about this one already. Okay, when we talk about register. I mean, when we talk about register addressing mode. So it will directly refer to this. So what is inside R1 is the operand. So the operand is 450. Okay. So, and then the last one is register indirect. So register indirect. Okay, so it's pointing to whatever 2 times. 1 time is to the register, another time is to the operand. So means that this time your register actually point to here is 400. The effective address is going to here. So this is your EA for your register indirect. So it will be something here, EA here, and your operand will be here. So your operand will be 1000. Okay. Okay, yep, that's it. Okay, any problem? Okay, no, No. Okay, good. Hopefully it's clear for you. If you have any problem, you just try to email me. I mean, in case you have any doubts. Okay, so thank you everyone for today. And we'll see you next week. Thanks, and you can leave the meeting.